Okay, meet you again. My name is Satrio Wicaksono, and I'm here to teach you about Introduction to Engineering Design. And the topic for today is electrical and control. Okay, before I start everything, I must tell you about it. There are some slides that I will skip in this video because the explanation will be too long. But I believe you have studied in high school, and I believe you can study it by yourself. So the things that you can study by yourself, I won't be explaining in detail. But some application that are still new, I will explain it in detail. Okay, as usual, we started off with the expected outcomes of this week. Okay, the first one is students understand how electric motors and generator work. Students understand about system control, and students able to identify the elements in particular system control. Now about the electric first. Okay, there are two different type of electricity. The first one is alternating current. The second one is direct current. Okay, the motor itself can be divided into those two: direct current motor and alternating current motor. Okay, same as generator as well. It can be divided into two: AC and DC generator. For battery, most of the time it's direct current. Okay, now what are the differences between AC and DC? Okay, the current itself is different. Okay, but what else? I believe you have studied it in your high school day. Now, I want to discuss about what is electric motor. Okay, in our life, there are several usages of electric motor. For example, I believe you have water pump in your house, and it's using electric motor as well. And if you think about it, actually 70% of the electrical load in industry is because of electric motor. Okay, now the first one, DC motor. The principle is very simple, and I believe you have studied it in your high school day. So before you go inside of my class, please reread everything. Okay, I might ask you inside of the class about this. Okay, now I want to discuss about the AC motors. It can be divided into two. Okay, synchronous motors and induction motors. Okay, what's the differences between these two? Actually, I will discuss it in more details inside of the class. Okay, but because it will take too long in order to explain in the video, I will just skip it. Now, generator. What's the difference between generator and motor? Okay, motor will use electrical energy in order to move, but generator is the opposite. You need to move it in order to produce electricity. Okay, the principle, I believe you have studied it. Actually, you can see in this slide, this is the principle of generator, and it's better for you to read about it, and later in the class I will discuss it in detail. Okay, now the generators for DC, for direct current. Okay, we normally call it as dynamo. Okay, and I want to ask you, I'm not so sure whether you know about it or not. You know where is the application of dynamo? Where you normally see dynamo? For all people, I believe they will know. but for you, I'm not so sure. If you have seen your grandpa bicycle, maybe you will see some dynamo there. If you look at the front wheel, and there are small things attached near to the wheel, okay, and when it's attached, okay, and you run the bicycle, you can light up the light. If you think about it, that small part that is attached near to the wheel is actually a dynamo. But I'm not sure. Maybe you have never seen one. It's better for you to search for it in the internet if you have never seen one. But some, maybe you have seen it. I've seen it, but I think I'm older than you, so that's why I've seen it. Okay, and now the next one is generators for AC, or we call it as alternators. Okay, the same. I want you to try to search where it normally is applied. Okay, I will give you some hints. You can find it inside of a motorcycle. But it's better for you to look for it as well, in which part it's installed. Now, battery. Okay, battery is actually a device consisting of one or more electrochemical cells that can convert the stored chemical energy into electrical energy. Okay, the development of battery from year to year is actually, the development is inside of the component. Okay, in the last 2 decades, there is lithium, not lithium actually, alkaline battery. Okay, in the last 2 decades, I first found it around early 1990s or late 1980s. But nowadays, the most common one is lithium. I believe you can find it inside of your cell phone batteries. Okay. Now we will move to the next part. Is fuel cell. What is fuel cell? It's actually one of way to create electricity from hydrogen. Okay. How does it works? Okay. Because the process is quite complex. Try to search for it. In the class, I will discuss it in detail. Now I believe that this part, okay, the second part of today's video, control, is new thing for you. That's why some part I will discuss in more detail in comparison to the previous part. I believe you have done this kind of thing. Okay, you fill water inside of a glass. But sometimes if you can't control it, okay, the water will spill out. Okay, but if you control it, you will get just enough water inside of the glass. Okay, there are two kinds of control: open loop and closed loop. This is the normal things that we do. The closed loop, okay, the control is actually using our eyes. When we see the water level, we see whether we have to turn the tap off or turn the tap on. If it's still empty, you will turn the tap on, but it's already almost full, you will turn the tap off. Okay, so actually the control is using your eyes. Now, there are several devices here. How does the control works in these devices? Try to think about it first. Okay. Some of it are using a manual control using our eyes, but some of it maybe not. Okay. This is the control system element. At the beginning, there is a reference value, and using comparison element, we can compare the measured value with the reference value. If there is an error, we will process it using our control unit. After that, to the correction unit, and we will process it. Okay. This is the first example. AC, air conditioning. What is the control variable? What is the reference value? What is the comparison element? Okay. All of the components, what is it? Try to think about it first. Okay. The control variable is actually ambient temperature. Now, what is the reference value? I believe when you turn on air conditioner, you normally set up the temperature. The temperature that you set up is actually the reference value. Then the comparison element is a thermostat. The error signal is the difference between your temperature, your temperature that you set with the ambient temperature. Is the temperature difference. Okay, is the error signal. Then the control unit is thermostat. The correction unit is the air conditioning unit. The process is changing room temperature. Then the measuring this device is thermostat. Okay, so actually it's not that hard. So the control is, as you can see in this picture, it's not that hard. Okay. Actually, there are several other examples that I can give you, but the problem is it will be too long to explain everything. The other example I will show it to you inside of the class. Now, I want to discuss about the purpose of the control. There are two main purposes of the control. The first one is to regulate, to maintain certain steady state condition with respect to disturbance. And the second one is to manipulate or to perform specific predefined tasks. Okay, that's the purpose of control. Now, when you control a system, the system itself has qualities. There are several things that define the system qualities. The first one is stability. If you look at this picture, okay, the picture on the left is a stable system. Why? Because the ball here won't be able to drop anywhere. It will be just stay there. But if you look at the picture in the middle, it's unstable just because of small disturbance. Okay, the ball will drop. It's one example of stable and unstable system. Besides stability, the quality of the system is defined based on its performance, robustness, as well. Okay. Now the challenge in controller development, there are two. The first one is to determine a proper corrective action from the controller that result in system stability. The second one is to determine a proper action from the controller that results in new desired condition. Okay, actually that's all for today. Please study the things that I've mentioned in this video. So inside of the class, we will have a better discussion. Okay, see you in the class.